Alright, what's going on, dude and dudettes? Welcome to Eric's gnarly outdoor classroom. Today's topic of discussion, the wave. Alright, so there's a lot to cover on this subject, but we're going to try and stick to some of the most important parts. Like, for instance, we might discuss the different types of waves that exist out there on the great blue yonder. Or we might discuss how they form, and maybe some of the devastating effects that these waves have on our coastlines. Alright. So now if you want to follow me down to the water's edge down there, I'll give you a brief intro on how these puppies form. Hey everyone, how's it going? Here we are again. We were just having some fun back up there, but now we're going to get a little bit more serious and discuss how these waves actually form. Now, waves can be found not only on the ocean, but on lakes and ponds as well. These waves behind me are pretty average for the Southern California coastline, but you have to remember that waves can vary greatly in size. Anywhere from the small ripples found in your backyard pond to the large seismic sea waves generated by tsunamis. Now, by this point, I'm sure you're asking yourselves, well, what causes these waves to form? Waves can be formed by many different types of generating forces. The waves that we see behind me today are created by the most common type of wave generating force, the wind. Waves are created by wind blowing over the sea. As the wind blows, it transfers some of its energy to the surface of the water and causes small ripples to form. These ripples, or capillary waves, are able to catch more and more wind, and thus the ripples become larger and larger as long as the wind continues to blow. Once the ripples have formed, the wind may have had an effect on creating a potential difference in the sea level between the windy area. Say, for example, the Caribbean and the other side of the ocean, say the Western European coast. This difference is known as a swell. And in order to try and flatten out the sea again, the swell moves across the ocean towards the lowest point. As the swell approaches the coast, the water continues to push inland where there's an underwater gradient to the land, such as a beach. Eventually, the swell cannot push horizontally anymore, and so a vertical component to the water is created. This is also known as a crest. Now, what I have just described to you is the beginning of a wave. Now, once the swell pushes the wave significantly high enough above the sea's surface, the wave becomes too tall to support itself and breaks, releasing its energy as it falls onto the beach. That's what's taking place behind us today. Now, if you would please give your attention to my good friend Chrissy, who is going to cover the different types of waves and wave energy. Take it away, Chrissy.